Okay, this is one final example of functions and their properties, just for those of you who would like to see a little bit more of it. So in this example, we have this graph. There are no arrows, so this is the entire graph right here. There are many points given on the graph, just so that we can be pretty accurate with it. All right, so when we start doing these problems, usually the first thing that we're going to be asked is for the domain and the range. Okay. So the domain in this case is this x values from left to right. Notice that the x of -6 is the lowest x value, and 6 is the highest x value. The range is the y values from bottom to top. So the lowest y value here is -2, and the highest y value here is 4. I'm going to use brackets on all of these because all those dots are filled in, so include the values. Okay. Another thing we might be asked on this graph is where the graph is increasing. So remember, increasing means that we're looking from left to right and we're going uphill. So here's downhill, here's uphill. Notice that the slope can change, right? Try to think of it as like skiing or sledding. So here's the uphill, and then you're going flat, and then you're going downhill again. So you're going uphill from just that one area, -4 over to 0. Remember that you're answering the x intervals. Okay, don't forget to only answer the x values there. All right, so then probably for letter C, we'd be asked, where is the graph decreasing? So where are we going downhill in this graph? Let's erase the uphill. Okay, so we start from left to right. Here's a downhill slope. Then we go uphill, flat, and then here's another downhill slope. So we have 2 intervals for this one, starting at -6, ending at -4, union with starting at 3 and ending at 6. In this graph, we would probably also be asked, where is the graph a constant? Remember, a constant is just going to be a single number. So a constant means that the graph is flat. So instead of increasing or decreasing. So right here, the graph is called a constant. So that interval is the x interval 0 over to 3. All right, another thing that we might be asked for in this graph is for any relative minimums or man, it's hard to spell that word. Okay, let me just try again. There we go. Minima, because there could be more than one. Okay, so when we're looking for a valley. Okay, so we have a valley right here, the bottom of that valley. And then we really don't have any other valleys. Okay, this is an endpoint, so it doesn't count as a relative minimum, although it could be the lowest point overall, but it's not in this case. So the relative minimum, the lowest point we have, the value is -2, and that occurs at x equals -4. We also then would be asked for the absolute minimum. Remember, that can only be 1, and indeed there is only one. It is the same value, -2, at x equals -4. And then we could also look at our relative and absolute maximums. So our relative maxima, let's see if there is a maximum or if there are more than one. We're just looking for the top of a hill. So here, yes, it's like a plateau, but all of that would count as the maximum value. So the maximum value is this high value here of 4. Okay? And that occurs at x, where x is from 0 over to 3, all those x values. Okay? And then finally, our absolute max is the same because that is the very highest point on the graph. 4 is the maximum value the graph ever gets, and that is at the bracket 0 to 3. Okay, so we may also be asked for this graph or for any function, where is the graph positive or where is the graph negative? And the way they would ask that would be, where is f of x greater than 0? They could ask greater than 0. They could say greater than or equal to 0. And then they could also ask, where is f of x less than 0? Could also ask less than or equal to 0. All right, so let's take a look at what that means. And I do like to kind of talk to myself awkwardly to re-explain to myself like what that means. So it's f of x greater than 0. F of x is the graph. Greater than 0 means positive, okay? This is f of x. Another way to say it is y. So where are the y values positive? So then I could highlight on the graph, okay, greater than 0. Well, it equals 0 there, but it's not greater. And then here, the graph or the y values are positive, and they're positive all the way over to here. Okay, so my answer is this x interval. Again, answer in x interval. Okay, so we're starting over at the x value of -2. And it is positive, the graph is positive until x is 6. And it's actually still greater than 0 at that point. So we want to include the 6 and use a bracket there. We use a parenthesis there because we want it to be greater than 0, not greater than or equal to 0. All right, and then to find, let's erase that. To find where f of x is less than 0 means where is y a negative number, or where is the graph below the x-axis. So that would be this portion of the graph, okay? Not including those zeros, even though the highlight looks like it did. All right, so we're starting here. It's still in the x intervals. And we're starting over at -6, and then the x ends there at -2. Use parentheses because we just want less than 0. We do not want it to include the 0.